Good day everyone! In this video, we will discuss about the properties of logarithms. These are the properties of logarithm. For b not be equal to 1 and b should be greater than 0 and m and n are elements of real numbers, the first property states that the logarithm of m to the base b plus the logarithm of n to the base b is equal to logarithm of mn to the base b. Meaning, if we are adding two logarithmic expressions, then we will be multiplying their respective powers. For the second property, it states that the logarithm of m to the base b minus the logarithm of n to the base b is equal to the logarithm of m over n to the base b. This implies that when we subtract two logarithmic expressions, then we divide their powers. For the third property, we have logarithm of m raised to n to the base b is equal to n logarithm of m to the base b. For this property, it implies that if the power has an exponent, then it becomes the multiplier of the respective logarithmic expression. The fourth property states that the logarithm of b to the base b is equal to 1. Here, we can see that the base and the power are equal. If this happens, then this logarithmic expression will be equal to 1. Number 5. The logarithm of 1 to the base b is equal to 0. Meaning, if the power is equal to 1, then the logarithmic expression will be equal to 0. This property came from the concept that for any base b, when we raise it by 0, then the value is always equal to 1. Finally, for the last property, we have the logarithm of b raised to x to the base b will be equal to x. Notice in here that the base and the base of the power is equal. If this is the case, then the entire logarithmic expression will be equal to this particular exponent. Let us use these properties in simplifying some logarithmic expressions. Simplify each logarithmic expression. For the first one, we have logarithm of x to the base 3 plus logarithm of 5 to the base 3. Number 2, we have 3 logarithm of x to the base 2 plus logarithm of 3 to the base 2. And for the third given, we have 2 logarithm of x to the base 2 minus logarithm of 3 to the base 2 plus 3 logarithm of x plus 1 to the base 2. Let us solve these examples one by one. For the first given, we have the logarithm of x to the base 3 plus the logarithm of 5 to the base 3 using the first property of logarithm, which states that the logarithm of m to the base b plus the logarithm of n to the base b is equal to the logarithm of mn to the base b. Then, this expression here, the logarithm of x to the base 3 plus the logarithm of 5 to the base 3 will be equal to the logarithm of 5x to the base 3. Recall that when we are adding two logarithmic expressions, then we are multiplying their respective powers. Then, multiplying x and 5, then we will be having 5x. Therefore, logarithm of 5x to the base 3 is the simplified form of the given. Moving on to the second one, we have 3 logarithm of x to the base 2 plus logarithm of 3 to the base 2. So again, we are given 3 logarithm of x to the base 2 plus logarithm of 3 to the base 2. Using property number 3, we can simplify the first logarithmic expression into logarithm of x cubed to the base 2, then copy the second term plus logarithm of 3 to the base 2. Next, since this is addition, so we need to multiply the two powers. Hence, we're gonna have logarithm of 3x cubed to the base 2. Therefore, this is the simplified form of our given. For our last example, we have 2 logarithm of x to the base 2 minus logarithm of 3 to the base 2 plus 3 logarithm of x plus 1 to the base 2. So, let us rewrite first our given here. So, we have 2 logarithm of x to the base 2 minus logarithm of 3 to the base 2 plus 3 logarithm of x plus 1 to the base 2. Using property number 3, notice that we have a number here and also here. So, we will be using them as our exponents to the powers. So, writing it will become logarithm of x squared to the base 2, then minus logarithm of 3 to the base 2 plus the logarithm of x plus 1 quantity cubed to the base 2. Then, applying property number 1, since this is addition, then we simply need to multiply 3 and x plus 1 quantity cube. So, we will have logarithm of x squared to the base 2 minus the logarithm of 3 times x plus 1 quantity cube to the base 2. Next, since we have subtraction here, we need to apply property number 2, which states that we need to divide the two powers. So finally, we will have logarithm of x squared all over 3 times x plus 1 quantity cube to the base 2. Therefore, this is the simplified form of the given expression. Also, the properties of logarithm can be used to expand logarithmic expressions. Let us try to solve the following given. The first one, we have logarithm of 3x to the base 4. Number 2, we have the logarithm of 16 over x squared to the base 5. And number 3, we have logarithm of 10 over xy to the base 7. Solving them one by one. For the first one, we have the logarithm of 3x to the base 4. Since the operation between 3 and x is multiplication, using property number 1, when we expand this logarithmic expression, then it will become logarithm of 3 to the base 4 plus logarithm of x to the base 4. So this is the expanded form of the given logarithmic expression. For the second one, we have the logarithm of 16 over x squared to the base 5. Since this is division, by using property number 2, so we need to subtract the two logarithmic expressions with powers 16 and x squared. So it will become logarithm of 16 to the base 5 minus the logarithm of x squared to the base 5. Hence, this is the expanded form of the given logarithmic expression. And finally, for the last one, we have the logarithm of 10 over xy. to the base 7. Since this is division, using property number 2, we will expand it by subtracting the two logarithmic expressions, logarithm of 10 to the base 7 minus the logarithm of xy to the base 7. Moreover, since this is multiplication, so we can still expand this logarithmic expression here, giving us with the logarithm of 10 to the base 7 minus the logarithm of x to the base 7 plus the logarithm of y to the base 7. Notice that I have enclosed them with open and closed parentheses because x and y are both on the denominator of the given expression. With that, simplifying them without the parentheses, we're gonna have the logarithm of 10 to the base 7 minus the logarithm of x to the base 7 minus the logarithm of y to the base 7. Therefore, this is the expanded form of the given logarithmic expression. I hope that you have understood the lesson. For the next video, we will discuss about logarithmic equations. Thank you so much for listening and see you on our next discussion.